Assalamualaikum warahmatullahi ta'ala wabarakatuh to our panel, Encik Syafawi and Dr. Adam, and also to my supervisor, Technologist Ashari. My name is Aminuddin bin Mohammad. My message number is CN190148. So today I'm going to present to you my bachelor degree project 2, and the title of the project will be Optimization of Boiler Feed Water Treatment through Very Softener Regeneration Process INLET FLOWRATE. And I will begin with the abstract. So water softening are the common method for treating the properties of boiler feed water to prevent scaling and corrosion. Softener regeneration process are essential to regenerate the resin bead through backwash, charge and rinse process. Universiti Tun Hussein on Malaysia, Biodiesel Plant current guideline are lack of information for the optimum flow rate in softener regeneration process and also the optimum dosage that needed for the chemical treatment. So the objective of the experiment is to perform boiler softener regeneration process with 5 different stages of flow rate and also analyze the boiler water treatment test such as sulphate test, hydrate alkalinity test and pH value using the BP 100 and 210 chemical. So the reading of the water quality will be analyzed at the end of the experiment to comply with the UTHM Biodiesel Plant water quality guideline. In future, this project can be as a reference for the softener regeneration guideline. Next, for the introduction of my project, first of all, what is hard water and how hard water can impact the water quality inside the boiler. So hard water that comes from the domestic water supply contain unwanted ions such as magnesium and calcium. Those unwanted ions will cause scaling and corrosion problem to occur inside the boiler. So this is where the function of the water softener. Water softener process will eliminate those unwanted ions by treating the hard water through ion exchange process, which require the use of resin bead. So after several time, the resin bead may be frazzled and exhausted and need to be regenerated through softener regeneration process for maintaining the water treatment quality. And then resin bead will be regenerated through softener regeneration process such as backwash, charge, slow rinse and fast rinse process for maintaining the water treatment quality. However, Universiti Tun Hussein on Malaysia Biodiesel Plant current guideline are lack of information about the optimum flow rate for the softener regeneration process and also the optimum dosage of chemical needed for boiler water treatment. So the objective of this project is to perform the boiler softener regeneration process such as backwash, charge, slow rinse and fast rinse through 5 different stage of flow rate and also analyze the boiler water treatment through sulphate test, hydrate alkalinity test and pH value test. So the purpose of this softener regeneration process is to ensure that the water quality of the boiler are complied with the guideline that have been set by Universiti Tun Hussein on Malaysia Biodiesel Plant. Next, for the literature review of the previous study, first of all, we got the water softening is the process of replacing scale-causing cation such as magnesium, calcium and calcium ion with sodium ion. This is from boilers at 2018. And the second one is the oxygen corrosion will end up causing pitting and rust deposit in the boiler tube. Hydrogen potential pH less than 9 can cause corrosion, while total hardness that higher than 2.0 ppm will cause scaling to form. This is from Mohammad during 2010. And lastly, the pure concentration alkali solution are among the softener chemical that being used in boiler feed water. This chemical react with calcium and magnesium compound. This is from Lentec at 2011. Next, for the methodology of this project will begin with the experiment for the softener regeneration process with 5 different stages of flow rate. So how to regulate the amount of flow rate that pass into the softener tank. So there is a manual hand valve at the softener tank. So student will manually adjust the manual hand valve for selecting the desired amount of flow rate and how to monitor the amount of flow rate. So there is a pressure gauge that indicate the water that flow into the softener tank and on how to adjust the softener mode into the backwash, charge, slow rinse and fast rinse. So basically there is a softener handle which is used to selecting the softener mode for the softener regeneration process. And after that, the result of each flow rate will be analyzed through pH test and total hardness test. So for every flow rates, water sample will be taken and will be tested to the total hardness test. And the requirement of the total hardness test is that the sample water must be below than 2.0 ppm of total hardness. So if the water quality comply with the total hardness test, then student can proceed to the next step and also choose the suitable flow rate that have been previously done. So after the water quality pass the total hardness test, boiler will be run at 8 bars and boiler water sample will be taken. The method of collecting the boiler water sample are using the blow down method. So student will take about 500 ml of boiler water and bring it to the Biodiesel Lab for the water quality treatment. So boiler water sample will be analysed with pH test, sulphate test and hydrate alkalinity test using the BP100 and BP210 chemical. So BP100 serves the function to increase the sulphate value, and BP210 serves the function to increase the pH value and hydrate alkalinity value. For every dosage of chemical addition will be recorded and will be analysed, and at the end of the experiment, student will come out with the optimum amount of dosage for the chemical needed inside the boiler water, and also the optimum amount of flow rate for the softener regeneration process. Next, for the result and discussion of my project, after done the experiment, students have determined the optimum flow rate for softener regeneration process that comply with the guideline for boiler water quality in Biodiesel Plant. Then the dosage of chemical needed for boiler water treatment have been identified for stabilizing the amount of sulphate, hydrate alkalinity and pH value in the boiler water. So in the left section of the result and discussion, you can see this is the table for the recommended or optimum flow rate that have been identified by students throughout the experiment. And this is the chart for the optimal flow rate for the softening regeneration process. So as you can see, for the recommended flow rate for backwash process, student identified that at 58.0 was the optimum amount of flow rate for the backwash process, and for charge process require a much lower flow rate at 4.0 psi, and as low rinse process require at 5.0 psi, and fast rinse process at 12.0 psi. For all of this flow rate, student recorded that the amount of pH value and total hardness are consistent from 8 for pH value and 2.0 for total hardness, which comply with the guideline for water quality in UTHM Biodiesel Plant. However, you guys must be wondering on how students obtain the optimum amount of flow rate for each of the softener regeneration process, such as backwash at 58.0, charge at 4.0, slow rinse at 5.0 and fast rinse at 12.0. So one of the method that students use are dividing the amount of flow rate for each process into 5 different stages of flow rate. As an example, for backwash process, the previous method that have been used for backwash process is at 72.0 psi, which is the maximum operating for flow rate for the softener regeneration process. And then student divide the 72 with 5 to obtain the gap between every amount of flow rate and come out at that 58.0 is the best optimum flow rate for softener regeneration process. For charge process, student identify that require a much slower process from the online research and also an advice from the technician and expertise. Same goes to the slow rinse and fast rinse process. So as a comparison between the previous guideline and the proposed guideline is that from the previous guideline, they use a higher flow rate for all of the softener regeneration process, which is 72.0 psi. So for backwash process, they use 72, charge, slow rinse, fast rinse, also they use 72.0 psi. So this experiment that have been conducted identify that there is no need to use a high flow rate or a maximum operating flow rate at 72.0 psi if we can use 58, 4.0, 5.0 and 12.0, but also still achieve the water quality data that comply with the recommended limit that have been set by UTHM. So by regulating the amount of flow rate for the softener regeneration process, it can really impact the result of the water quality, and then the recommended amount of flow rate that have been choose show a constant pattern of water quality of the pH value at 8 and total hardness at 2. So this is my proposed guideline for the optimum flow rate to be used in the softener regeneration process. Next, the objective of my experiment that I have previously mentioned is to find the optimum dosage of chemical needed for treating the water using BP100 and BP210 chemical. So at the right section of my result and discussion poster, as you can see, this is the table for the data that have been obtained from the sample of boiler water before the experiment will be conducted. So this is the water quality data. For the boiler water sample, it contain pH value at 9.0, which doesn't comply with the fundamental control limit, and then hydrate alkalinity at 65 ppm, which also doesn't comply with fundamental control limit, and the same goes to the sulphate, which is at 16 ppm. It doesn't comply with the water quality limit that have been set by the UTHM Biodiesel Plant. So in order to overcome this problem on how to increase the amount of sulphate, hydrate alkalinity and pH value, so we must add a specific chemical that need to be used for treating the boiler water, which is BP100 and BP210. Those chemical addition will help to increase the amount of pH value, hydrate alkalinity and sulphate. So this is the first charge of the chemical addition in the boiler water. So for increasing the amount of sulphate, we use the BP100 chemical, and after the process of addition chemical have been done, student identify that at 1.0 kg, we can increase the amount of sulphate from 16 ppm to 35 ppm. And for increasing the value of pH using the BP210 chemical, at the dosage of 3.0 kg will increase the amount of pH value from 9.0 to 12.0, which is within the fundamental control limit. And then lastly, for increasing the amount of hydrate alkalinity using the BP210 chemical, student identify that it perform best at 2.5 kg, which it will help to increase the hydrate alkalinity from 65 ppm to 274 ppm. So basically, the chemical that have been used in boiler water for increasing the value of pH and value of hydrate alkalinity are same, which is BP210 chemical. So as a conclusion, we can conclude that the recommended limit or the optimum dosage for the chemical addition to treat the boiler water is at 3 kg of BP200 chemical, and then for BP100 chemical is best performed at 1.0 kg. For the conclusion of my project, at the end of the experiment, all of the objectives have been achieved. Firstly, the objective to find the optimum flow rate for the softener regeneration process have been achieved. And next, for the dosage of chemical needed inside a boiler also have been identified for stabilizing the water quality using BP100 and BP210 chemicals. So lastly, the reference of my project. The first reference I refer to the literature review. The first reference contribute to the boilers as the writer, and the second one is Mohammad during the 2010. This is where I cite it from the second of my literature review, and the third literature review will be the contribution for the Lantet for its writing during the 2011. So there is a QR code that have been prepared for panel and also for our supervisor to see the progress of my project, and also to see the data recorded and chart for the water quality test, and also I have prepared the comparison side by side between the previous guideline and with the newly proposed guideline, and also I have explained in detail about the procedure of softener regeneration process using the flow rate that have been identified in this experiment. So that's all for my bachelor degree project presentation. Thank you so much.